Hello, and welcome to part 2 of The Hobbit, a challenge problem from the online book Clojure for the Brave and True. This is a great resource for learning Clojure. I highly recommend it. Before we get started, I want to show the function we'll be building in this video. It is called hit, and it takes one argument, the asymmetrical list of Hobbit body parts, which we are given as part of the problem. Each body part has a name and a size property. So we can call the function, supply it the asymmetrical list of body parts. The hit function will symmetrize the input parameter, then randomly select a body part from the symmetrical list and return that part. We worked through building the symmetrize function in the previous video. You can see here we got back, and if we execute it again, we should get something different, and yet something different again. Let's rough in the hit function to get us started. So we'll define a function called hit, and we know it takes one parameter. That will be the asym body parts. So let's just call it asym body parts. And this will be where we put the body of the function. We can right away compute the symmetrical list. So we'll put that in a new let binding. And we'll call it sim body parts or symmetrical body parts. And we'll just use that function we created in the previous video and pass it the asym body parts. And that's a good start. The next sub-problem we have to solve is randomly choosing a body part from the list. The first thing that might come to mind is just picking a random number in the range of 0 to 31, where 31 is the number of elements in the symmetrical list. This would be really easy to do. We can use the rand-int function, which just takes a value n for the upper range, and that we can just do a count on the symmetrical list. And so you can see here we'll get 22, 21, and that'd be easy enough. But even though this definitely produces a random number, it doesn't take into account the relative size of each body part. We can easily understand this if we imagine a list of two body parts, one with a size of 9, D9, and the other with a size of 1. Doing a rand-int in the range of 0, 1 would choose based on a 50% chance either 0 or 1. That doesn't reflect, however, that one body part is so much bigger than the other. A better approach, which takes into consideration the size of each body part, would be to sum all the sizes and then pick a random integer in that range. To explore that a little bit, we'd have to determine the total size count of the symmetrical list. And with that, we could do that with a reduce. And we'll pass in, we want to add all the sizes. And so what we can do is now pass in for the collection the list of sizes from the symmetrical loop. This is pretty straightforward with the parts that we already have in play. If we do this, we get 85. Let me just bring that over. Producing a random integer in that range is easy. You can just do this. You see we get 62, 58. Now we would have to figure out how do we go from this random integer to find the body part. What kind of data do we have at our disposal? Well, we can pull out the individual sizes from the symmetrical list. That should be pretty easy. So we can say, let's map over the symmetrical list. We'll compute that again. And the function we want to use as we map over is the size key of the body part. And you recall in Clojure that you can use the key of such map data structures to get at the values. So if we execute this, we get this nice list of sizes of each body part. Let's just signpost this here for ourselves a little bit. We'll say these are the individual sizes. We could also calculate the accumulated sizes. This we can do with a reduce function. So let's rough that in. We'll put in a anonymous function, and we'll say the thing we want to accumulate, we'll just call that the backpack. We'll put things in the backpack, and because we're accumulating over the symmetrical list, it's going to, the reduce will hand to this function the part. The backpack will start off as an empty backpack, and the collection will pass to it. Will just be the symmetrical loop. And then here we want to manage our backpack on every iteration that reduce is going to give us. So we'll say, look, we want to put into the backpack the contents of this little backpack, let's say, and that wants to be, we want to add. Now what we want to add is the last item that we put in our backpack. So we can say last, and then backpack, and then the current item we're about to put in the backpack, which would be the size of the current part. Now if we run this, see what it gives us. We get a null pointer exception, and I think I know why. So if we say last empty vector, we get a nil. But if we want to add nil to say 3, we get this null. So we have to check to make sure that this isn't nil when we're adding it. So to do that, we can use an if statement. And the test we'll do is check to see if the backpack's not empty. And the way that it's recommended to do this in Clojure is to use the seek function and pass it the collection. And we'll say, if you are not empty, then that means I can go in and grab the last thing I put in there. There's at least one thing to get. Otherwise, just return 0 to say that you're just empty. So if I run this, I get that. If I bring this over, let me bring this down. That roughly looks like the numbers are adding up, I'd say. Excuse me. would say that looks pretty good. One issue with what well, maybe not what an issue, but sort of a perception thing, is that this is a list of relative sizes, but we don't get a sense of the relative scale because we're basically using like a single slot to represent something that is size 3, of size 10, size 6, and 1. So I think I'd like to lay out all of these on a line defined by the range. So I just need to create a sequence from 0 to 85. That's really simple. We can say take the first 85 elements, and now I'm going to generate a sequence. I can use iterate for this, which takes a function and an initial value. So in this case, we just want to increment, which adds 1 to the number passed to it, and we'll start it off at 0. And so when I execute this, you can see that we got 84 at the top and 0 at the bottom. So let me bring that over and format it a little bit. And then let me line these two up with that one and see what we have. What I want to do then is say take this first element and then put it on that bottom line like this. So you can see here it takes up 3 slots. And then here we have the second one, third one, fourth, and we come to this one here, that would be 2, and so on and so forth. Instead of you watching me fill this out for the entire line, I'll just pause the video and do all of that, and then I'll just paste it back in. Okay, so what I've done is expanded those all out along a number line that basically goes from 0 to 84, and I've cut it in half, so to speak, so that it can fit on the screen and we can see the whole thing at once. Let's see what key we can find out. So let's imagine we random number generator picks this number, number 1, then we would expect this element, this part, to be the chosen part. And if we picked, say, let's pick another one, let's say 9, this we would expect to pick this element, this body part. And let's go up here, up into one of the 2 big ones, and we'll say 27, and that should pick this body part. Similarly, if we go all the way to the end and pick the boundary case, if the random number generated was 84, then it should pick this last body part, the right foot, I think. Okay, that might give us some data use cases to think about. Is there anything we can notice? Is there a pattern whenever we pick these things? One thing we can notice is that the size, the accumulated size, is greater than the target, the random target, this number here. So in our first example, 3 is greater than 1. The second body part we picked with 9, the size is 11, and that's greater than 9. 27 is greater than 33. That might be something. What would that sound like if we said it out loud? Well, when we process a list or a collection, we usually start from the beginning and then we iterate our way through all the elements of the collection. And so if we imagine ourselves in the iterative loop, and we're in this data use case, the target is 1, then the first body part will be presented to us in the first iteration, and we can say, hey, you're the part if your accumulated size is greater than the random number. So let's imagine we're in the case where the random number generated was 9. Well, then in the first iteration, 3, is that greater than 9? No. Is 4, is 5, is 6, is 7, 8, 9? No. And that would be good, because once we get to the iteration that presents this element, this body part, then we say the size 11 is greater than 9. That's my part. Okay, the talk through didn't throw up any major red flags. If we imagine going all the way to the end and we generated the uppermost bound number of 84, the loop would iterate through every body part, giving us the last accumulated size, which is 85, and then that would give us the last element, body part. Let's run with that, see where it takes us. So I'm going to bring back our hit function up here. And let's just put it down underneath our data. It's always good to see the data in front of you. And we already initialized the sim body parts. Easy enough. And now we want to do a loop. So it's loop recur stuff. Let's create a space for the bindings, and then a new line for the loop itself, the body part, and then what do we want coming incoming? We want incoming to be the symmetrical body parts, so let's just call that body parts. Whoa, what happened there? Hold on. Body parts, and we want to bind that to sim body parts, which we computed from the argument passed into the hit function. So that'll give us the parts. From there, we should be able to get our accumulated size, because that'll come from the size of each part. So that's good. We know we want to, in our loop, then track the accumulated size. So let's put in another binding, and we'll call it accumulated size, and let's just start it out at 0. Continuing the special form of loop, we have to have some kind of condition to protect us against the going into an infinite loop. So if we rough the space in for that if statement, we know that if the condition is true, we want to say, hey, we found our part, right? We went through iteration 1, didn't find it, iteration 2, blah, 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 all the way to this one. We got to here, we went, yep, this iteration found it, return me the part. So I'm just going to say we're going to return a part. We haven't defined or brought that into scope anywhere yet, but let's just spell it out. If the condition is false, that means we did not find the part and we want to recur the loop. So let's start the recur. We know that the recur must pass in new arguments to begin the next iteration. And we have 2 that we've specified, the body parts and the accumulated size. Now, part of the deal of loop recur is that you need to whittle down the incoming list by 1. So you sort of pop off one body part of this list, do your business logic on it, and then take the remaining part of the list and pass that back in as an argument in recur, so that the loop can start the next iteration with the list one size smaller, and we just keep going all the way down. So in our case, we want to send the remaining body parts. We haven't defined that yet. And we also want to do the accumulated size. The remaining body parts in this, we can get those set up by using destructuring. But where are we going to do that? Now let's just put it up here in the body parts. So what we'll do is we'll say, let's destructure this, and we'll destructure it into 2 things. The first one we'll call part, and the rest we have to use this ampersand here to tell Clojure to take the first element and put it aside and call it part, and then put the rest in something that we're going to call remaining body parts. Okay, so that gives us the part we want, and now we have to calculate the accumulated size for the next iteration. So that we want to add. We want to say, let's add accumulated size, and then we want to just take the size of the part we're on. So last thing we got to worry about here is our check. Now from our look at the data, we said we can tentatively assume that the accumulated size of the part that is targeted will be greater than the random number generated. So we can say, look, if the accumulated size is greater than the random target, now we haven't calculated that yet. Now that is going to be a number that we just need to generate once whenever the hit is called. So we don't want to put that in the loop, because that will be rebound every iteration of the loop. So let's put it into this outer scope of the let. We'll call it random target. And we know we want to use rand-int, and then we want to pass it the total size count of the symmetrical list. So for this we can do reduce. The function we want to do is just the addition function, and we want to pass it a collection of all the sizes. So we can say, let's map over the sim body parts, and we want to use the function, the keyword size, which is the key name of the size attribute on the body part. Now let's register that, and let's just give it a call. Let's see, is it going to puke, or is it going to just give us something? Okay, we got something, and it's different every time we call it, but how do we know that the random number it generated actually corresponds to the body part that we returned? Good question. Let's just give ourselves a chance to eyeball some things. So we'll say print the random target, the accumulated size. Let's do the part. And is there any other? Actually, let's right here do the count of the sim body parts. Let's see what happens there. Call that. Hold on, that's way, oh, yeah, we don't want to do this. Don't want to print that whole list every time. We want the accumulated size. Let's try that again. Okay. Well, we can see here that 76 is greater than 75. I don't want to count through all those. Let's go through it again. You know what we'll do? Let's hack this a bit. I'm going to just put in a target. This will just be temporary, but it'll allow us to specify the target manually, and so we can quickly just pinpoint and focus on the use cases that we care about. So let me just pull the... Oh, I always do this. Okay, let me just cut this out, place it with target, and I'll just put it into a comment up here because we'll be putting it back. But at least here now we can walk through our 3 at least. Maybe we can add more later. So the first one we said is if the random target is 1, we want to get the first element, which we know is the head. So if we try that, oh, hold on. We register it, call it again, and it returned the left eye. Why did it return the left eye? Okay, so if this is the first iteration, the accumulated size is not 0. It should be 3. So we need to not set this to 0. We want to set it to the size of the current part. So will that make this work? Yes, it does. So that works. Now what if we pass in a 9? So we say 3, 10. So that's the mouth, and it's a size 1. And that is 1, 2, 3, 4, 5, 6 elements in. So 1, 2, 3, 4, 5, 6 elements in. That's interesting. But if it's 9, we wanted it to grab this one. What could be going on? Let's look at our numbers again. 3 is the size of the first element. 6 is 6. It should be 4. So how are we getting 6? Okay, let's walk it through. We're gonna get to our loop, and we're gonna set our accumulated size to default to the size of the first part of the loop. That gives us the 3, and in this case, you know, our target is the 9, so the accumulated size, you know, it'll fall to the false block of the if, and then we add what is the value 3 to the size of the, that's 3 again. Oh yeah, so we don't want that. We're adding the first part twice. So what we want here is we want to add the next body part, the size of the next body part. So in this case, the size of the left eye, which is 1. Can you see where we're going to get that? We have everything we already need to go and access that value. Right, it's in the remaining part. So we want the size of the first element in the remaining body parts list. Let's try that. Let's give our 9 again. And we get neck. So it's already starting to look like this is more right than what we had before, which was totally wrong. But let's look through our data again. So the first element here is the head and the left eye, left ear, right ear, mouth, nose, and sure enough, 11 corresponds to the neck. So that looks okay. Let's try our first one again. That should return the head. Okay, so we didn't go backwards on that one. Let's add 27. I'm thinking that's going to return the first of the two big body parts. And just to refresh our memory, that is, oh, hold on, I'll just do it over here. Oh, I don't want the ASIM one, my fault. Symmetrical loop, ASIM body, but this is the symmetrical list that we want. So 27, so the chest is the first one and then it's back. So this should give us the chest. And it does. We can quickly just make up a number, let's say 36. That should give us the back. And it does. And let's try 84. That should give us right foot. That makes sense. And let's pick a one that's like right on the edge. So like 56. Sorry, not 56, 55. Because that should pick the 56 one. So let's hit that one. That's the left kidney. Okay, so I think we might have it. I mean, we haven't really done any exhaustive testing, but this passes the first sort of, informal testing and building of it. I'll just comment out this print line just in case we ever want to bring it back. But I think that's it. That's our final hit function. Thank you for watching the video, and I hope you learned something while we were somewhere in the code.